Great. Let's get started. Good morning. My name is Nanda Kishore. I'm a PM in Azure IoT Solutions team. I'm really excited. I'm really excited because I see some repeats from the workshop yesterday. That means you want to know more about IoT in general. And today we're going to talk about how to build an IoT solution from ground up using reference architecture. Quick hands. How many of you are familiar with Azure IoT Reference Architecture? Okay? Oh, few. Hopefully, by the end of the session, all of you would be going back to that link and going through the document. I had two session goals. One, before we start talking about how to build a solution, let's understand what are the challenges involved in building an IoT solution. Why is it so complex? Why is it so daunting task to build an IoT solution? And why do we even have a reference architecture to help you start with? And then I'm going to give you a prescriptive guidance on how to build an IoT solution from ground up using a reference architecture as your guidance. Okay? So two goals. One is understanding the challenges. Second one, how to build one using reference architecture as a baseline. Before I get started, I have 4 MX tips to give away. Please pay attention. As we go through the session, I will be hinting on a couple of things, and I will ask them as a quiz in the end. If you answer them correctly, you will get the MX tip. And for the folks who attended the lab yesterday, if you answer them correctly, let's give an opportunity for somebody else to take the MX tip. Okay? With that in mind, what is an IoT solution? IoT solution in general has 3 segments. It has things, insights, and actions. Things are the devices that are deployed in field that generate the data. Once you generate the data, you want to take the data from these IoT devices. These could be like sensors, actuators, could be anything that are deployed in the field. You want to take the data and push it to the cloud. You want to push it to the cloud so that you can run some kind of an analysis to gain an insight. And once you gain an insight, you want to do something with it, take an action. You want to take an action by integrating with your line of business applications, or you could be performing a maintenance, or you could be doing a proactive or predictive analysis. Right? So use this to ground yourself when you're trying to build an IoT solution. It should have 3 different components: things, insights, and actions. Things generate the data. Insights will run on top of it to get you the insights, and then you're going to take an action from the insight that you just gained. But we all know building an IoT solution is a lot more than having these 3 segments, right? You need to worry about how do you manage these devices at scale. You could have hundreds of devices or millions of devices. You need to figure out managing these devices in scale. End-to-end security. How do you build this from ground up? How do you make sure it's highly available and it has a disaster recovery enabled? So over the next few slides, we're going to double-click on some of these challenges a little more, and then we'll pop back up and talk about how do we build a solution. So what are the design challenges in building an IoT solution? Network is a very key factor. We're innovating heavily to solve the challenges related to network of an IoT device. If you think about IoT edge, we're innovating in the IoT edge or the intelligent edge just to solve the problems related to network. Your devices could be connected in a network which are kind of shady, on and off, may not be always available. How do you deal with these devices that are not always connected? You may need to do some local processing on the devices. That's where the edge will come into play. As I walk through these challenges, I will also hint at the IoT solutions that you can leverage from Azure to solve these challenges. So when you're dealing with a choppy network or a network latency that you cannot deal with, IoT Edge is a great thing to think about. Oh. Protocol. So you have a lot of great cloud-native protocols when you're building an IoT solution. HTTP, AMQP, MTTT are great, and if you're building a greenfield solutions from ground up. But if you're dealing with a brownfield scenarios, or if you're dealing with a specific industry segment, you have to deal with a lot of non-cloud native protocols, such as Modbus, predominant in the Industry 4.0 factory world, or BACnet, if you're trying to do an automation of like connecting different buildings. Now, we're trying to bring down some of these barriers by joining OPC UA. OPC is an open source framework platform where Microsoft is a major player. We're trying to bring down some of this barrier in the Industry 4.0 world by publishing a GitHub repos and also having some of the solution accelerators that are built on top of the OPC UA platform. Security and privacy is a paramount when you're building IoT solution. We're talking about millions of devices, not thousands. How do you make sure it's secure? We're innovating in Azure Sphere. You might have heard of Azure Sphere as a solution that we are innovating to solve the challenges related to IoT devices. When we talk about 80 billion devices, 80 billion IoT devices by 2025, according to Gartner, out of these 80 billion IoT devices, 3/4 of these devices will be the MCU, the small microcontroller units that go into refrigerators, microwave, or the kids' toys. And these are highly vulnerable when you think about security. And that's why we are innovating in Azure Sphere, having a secure OS, which is a Linux kernel running on a secure hardware with a root of trust, connecting back to the cloud securely. So think about Azure Sphere as a security solution from an MCU perspective. Heterogeneity, you have to deal with various different operating systems, Windows, Linux, real-time operating system. IoT Hub as a cloud gateway helps you address some of these challenges. Serialization, many of you are very familiar with how to transmit the data using JSON and XML. But when you want to transmit high-density data, high-density binary data, protocol buffer is an excellent choice if you want to have a lightweight serialization. Streaming throughput, you're trying to stream from millions of devices, or it could be streaming from devices which are not on network all the time. You need to plan for how do you think about streaming the devices. Do you want to do a store and forward, or you want to store them locally on the edge and do all of the processing? Cost, this is one of the reasons why many IoT solutions are stuck in POC. They're stuck in POC because we don't know how much it will cost, and what I may end up paying for it. If you want to do a proof of concept, if you want to get your hands kind of dirty just to play with the IoT solution, IoT Central is a great place to start. A fully managed SaaS solution that you can run and build POCs. If you have only 5 or less devices, you can almost run it for free, just to do a POC. But if you want to build up from scratch, solution accelerators that we publish is another great place. These solution accelerators are open source, published on GitHub for you to leverage and use it. And when you're using them with Azure services, it will cost you less than $500. Device provisioning and management. So how many of you are familiar with Kafka? It's an open source, couple of them. Good. The challenges with Kafka is it's a great system if you want to do a high data ingestion into a cloud. It's an open source solution. You can go and get it. But it has none of the device provisioning or device management things that you need as built in. You have to build those solutions from scratch on your own. IoT Hub will solve you those problems. We'll talk about them. Data volume. No data in IoT world is bad. You don't throw away any data in IoT. You just layer them differently and store them. So you need to plan for what is my strategy for hot, warm, and cold data storage. Greenfield and brownfield, I talked about it. If you're lucky, you get to build an IoT solution from ground up. You can use a cloud-native protocol, or maybe you deal with some of the industry legacy protocols. But majority of the time, we're dealing with brownfield scenarios where the devices can barely connect to a network, or they don't speak the same language. We publish a ton of modules on GitHub that will help you transform the data or transform the protocols. So if you look at the Azure GitHub repo, you will be able to leverage them for your brownfield scenarios. Last but not least, HA and DR. All of you are very familiar with this. So to have any highly scalable solution, HA and DR is a must. You can't have a production grade scenario without an HA and DR, and we will talk about how to solve that using Azure PaaS services. With these challenges in our mind, let's talk about few more variables that will drive your architecture. Are you familiar with 3 variables or 3 V's with respect to big data? Volume, velocity, and a variety. Same principle applies to IoT as well. In terms of devices, messages. How many devices you're trying to connect? How many messages you're trying to send? What is the frequency? Do you want to send them right away, or do you want to store and forward? It really depends on what kind of network you're running. If you're running on a choppy network, you may want to do a store and forward. Or if you're running on a network which is not connected, you may think about edge. Same thing, variety of data. You want to stream it all the time, or you want to probably do a store and forward, alert them, right? Then IoT solutions need to think about communication. Do you want to just have a communication going from devices to the cloud? That means you want to send the telemetry data from devices to cloud. More often than that, you want to have a bidirectional communication. If you're thinking of using a cheaper solution like Event Hub, you can only have a one direction, that is, you can send the data from devices to cloud, but you can't have a bidirectional command and control. That's where the IoT Hub will come into play, right? Now, by now you're thinking like, gosh, this is a lot of complexity. How do I build a solution, right? I'll give you some design principles, and then we will talk about how can we help you get through these challenges using our reference architecture. The first design principle is about storage. So I was talking about this yesterday. Please do not use relational database for all of your IoT solution. So as I was mentioning, gone are the days where you use the relational database for all of your IoT needs. It is okay to embrace polyglot when it comes to database choices. Use a different data store for hot, different data store for warm, different data store for cold. It's completely okay. And that's how you should build an IoT solution as well, based on your data type. And also, when you're trying to use a type of a data store, consider your skill set into account as well. I'm going to repeat the same thing. Gone are the days where you will build a solution on IaaS. Please use the PaaS services. You don't want to be building on IaaS and dealing with patching machines, dealing with security vulnerabilities that you need to think about day in and out. Let the Microsoft deal with it. Use the PaaS services. That will help you make sure that you can get with your solution faster, have a high availability and disaster recovery built in. You can think of managing it as a configuration, as a code, instead of trying to build them from scratch. So use the first principle, use multiple databases, that's completely okay. Second principle, use PaaS services, do not start with IaaS. Last but not least, if you use the PaaS services, your components will be redundant. It's ready for operations to use, right? So scale out all of your components as much as possible, and also plan for scaling in. If you're not using it, scale back in. In that way, you will save cost as well. Now, I've given you challenges. That's a lot of them. A couple of principles, we talked about it. So now let's see how can we build a solution using reference architecture. Or before we get there, quickly, there are a couple of things that we offer in our portfolio. If you want to just use an IoT solution, IoT Central is a great place to start. It is fully managed in the cloud. You don't have to worry about deploying any infrastructure. It's almost like Office 365, or it's like Office 365 for your IoT solution. Connect your devices. You can do the rules processing. You can take actions, all of them on the cloud without deploying anything, and you can be up and running in minutes. But if you still want to build something from ground up, we publish open source solution accelerators. We've done a market study and try to understand what are some of the common patterns, what are the table stakes when it comes to building an IoT solutions, and we built those table stake solutions for you and put them on GitHub. They're completely open source. Those are remote monitoring, predictive maintenance, and connected factory. It's yours to use. Go ahead and clone the repos, customize it. If possible, give us back to the community so we can take the leverages of benefits from your solutions. But it's yours to use. You can customize and use it. Remote monitoring is one of the most popular flagship product. So it's the most popular solution accelerator that people are using it to jumpstart their solution development. But if you still choose to build from ground up using the Azure services, start with the PaaS services. These PaaS services will help you jumpstart your journey, and we will go over how to use these PaaS services to build in compliance with the reference architecture. If you are new to reference architecture, please bookmark this. It's aka.ms/IoT Reference Architecture. We published the reference architecture a couple of months ago. It's about 60 pages white paper. You don't have to read all of that, but I highly recommend you read the first 5 to 7 pages. The first 5 to 7 pages will give you a complete overview of how to build a solution from ground up, all of the subsystems that you need to have that we're going to discuss over the next few slides. Going back to what I talked about earlier, you're all grounded on the principle that IoT solution only has 3 different segments: things, insights, and actions. Now we will begin populating each of these areas with a PaaS services and with a specific subsystem layers to help you to have a comprehensive solution. Starting with things, you have devices, hundreds of them or millions of them. Once you have a device, you want to transmit the data from these devices to the cloud. You need some kind of a cloud gateway. And you need to have a data device management as well. Once you transmit the data from your devices to a cloud gateway, you need to consume the data from this cloud gateway and do the rules processing. Do some kind of an analysis so you can gain the insight and store them in your storage. Once you gain an insight, you could simply have a reporting or a UI or integrate them back into your line of business applications for further actions. Those actions could be anything that I talked about, right? It could be just an alarm generation, alerts, or it could be in terms of doing a predictive maintenance or proactive maintenance. Now that we laid out the core subsystems, let's layer in the additional complexity that is required to build a comprehensive solution. You have edge devices because you're running on a choppy network, or you want to move the insights and actions closer to the devices, closer to the place where you live in. You have a powerful IoT devices that is capable of running the modules that runs on insights and actions. You need to think about planning for IoT edge devices. How do you provision millions of devices? When I talked about 80 billion devices by 2025, according to IDC, that means, imagine, million devices are coming online worldwide every hour. That's a staggering amount of devices coming online with the IoT sensor capabilities enabled. You need to have a way of provisioning them in bulk. So that's where the bulk device provisioning is required. Data transformation, it's an interesting thing. As you take the data from your devices and transmit back to your cloud and try to store it in your storage, you may have a need of transforming the data before you store it. This data transformation can happen in many places. It could happen in IoT edge devices if you have the capabilities or if you have the modules, or it could happen in the stream processing before you store it in your storage, or in general, you may want to process the data or transform the data before you store it. So it can happen in very different places. This is an example of like one common thing that we typically do. Now we are refactoring our storage layer that I talked about. You're kind of moving the storage into a multi-tier. You have a hot, warm, and a cold. Not every data needs to be in hot. You probably want to store the data that's required to take an actions right away, alerts in hot. Store it in the warm if it's for not required right away. You want to store everything else in your cold storage because you're going to run the machine learning and AI on top of it. So you don't delete any of that. Please leverage the layered storage to make sure that you don't lose the insights you can potentially get. If you want to run a predictive analysis or predictive maintenance, your cold storage is key. You need to be running your machine learning on top of the cold storage data. The more, the merrier. So the more data you have, it's better. You're going to do user management using Active Directory. So now that we talked about the core subsystems and all of the subsystems that are required, let's layer in the cross-cutting needs. What are the cross-cutting needs that you need to have across all of them? Security is the fundamental cross-cutting need across all of them. We think about security in three different ways. One, how do you make sure that devices that are deployed in the field are secure? They're authenticated and authorized to send to your cloud gateway, not to somebody else. Once you send the data to the cloud, you have to make sure it is happening securely. Security during the transmission of the data. And once you transmit, you have to make sure the secure data is stored securely at rest in one of the storage layers. Deployment. Look at the complexity of an IoT solution. You need to plan for deployment of these IoT solutions using Azure ARM templates or orchestration using Kubernetes and Docker containers. It needs to happen across all of these segments. And then it goes without saying, as I talked about, high availability and disaster recovery needs to happen in each of these components. Let's talk about the technology choices. This is probably what some of you have been waiting for. We recommend IoT Hub as the cloud gateway of choice. It provides you the capabilities that you need to provision millions of devices at scale through the IoT Hub device provisioning services. IoT Edge is the recommendation for the edge solutions. Azure Stream Analytics for rules processing. If you want to do a simple rule processing, you can probably get away with Azure Functions, but Azure Stream Analytics provides you a comprehensive rule processing that you can use for any of the IoT scenarios. When it comes to hot, warm, and cold, we recommend TSI for hot. TSI is a great solution for hot storage. It has an in-memory database and data running on SSDs stored up to 400 days for your all the needs with respect to alerting and visualization. Cosmos for warm, and then we recommend Azure Blob for all of the cold storage. Store it away forever. Then Azure Functions, if you're doing a data transformation, if it's necessary. Azure ML for machine learning. Line of business application integration, it could be Dynamics, or it could be anything else that you have through the logic apps. We use React.js and JavaScript to build our UI, and AAD for user management. Take a good look at these. These are the technology choices that we use to build our internal solution accelerators. This is exactly what we use when we are building our own solutions as well. For my cross-cutting needs, RBAC, PaaS, AKS, we talked about them. If you're taking pictures, go for it. Oh, sorry. The slides will be posted offline, so you can always go back and refer to this. Okay. We didn't arrive at those technology choices subjectively just because we like them. We ran them through an analytical process and subject them to the same common criteria across all of the segments: security, performance, scale, and cost. We want to make sure it meets all of these requirements for all of the subsystems that I talked about. Simplicity is a variable. What is simple for Microsoft may not be as simple for you. So when you refer to our Azure IoT Reference Architecture guide, we do provide the technology options. We say, like, if you cannot use this technology for various reasons, expertise or something else, you could use something else. We do have options that you can fall back to. And when we analyze the storage layer, we want to make sure it has all of the right query capabilities, query performance, and the caching that is required for hot and warm. To wrap it, Azure IoT Reference Architecture is foundational to build an IoT solution in a cloud-native way. It will help you factor your subsystems in a way that can be independently deployed, managed, and scaled. You won't be locked into a specific technology. You can plug and play your technology of your choice if you start with these subsystems. It is comprehensive because we are yet to come across an IoT solution that do not require all of the subsystems that we talked about. And you can always tune it to your skill needs. It's reliable because this is what we use internally when we are building our solutions. And this is what some of our elite partners and some of our largest customers are using when they're building their production gate solutions in the real world. But by no means we're complete with respect to how you can architect your solution. We want to hear from you. If you think there are certain areas that we're not doing as good of a job in terms of the recommendations, please do write to us. We want to hear from you if you have a recommendation that we should think about, or if you have a recommendation in terms of the areas that we should consider adding into your reference architecture, we want to know. Or if you want to contribute, you have an expertise in certain area that you'd like to contribute as a thought leader in the reference architecture, please do let us know. Some of the resources, please bookmark the reference architecture, aka.ms/IoT reference architecture. We're refreshing it every month. So go back to this URL regularly to see the latest content. Azure IoT Solution Accelerator is a great place for you to look into our open source GitHub projects that you can take and customize. As I said, remote monitoring is our most popular solution that you can clone and customize from there. With that, we are pretty close to our session time. I have 4 questions, depending on how well you've been paying attention. Okay, ready? What is the recommended choice for the cloud gateway? Thank you. Give me one good reason why Kafka won't scale for your IoT solutions. Excellent. Next, what is the most popular solution accelerator that I would recommend you go, clone, and use it? Excellent. The answer is remote monitoring. Last but not least, what are the recommended storage subsystem layers and the technology choice? Now, I need to know all of the recommendations on all of the layers. Who can give them? Excellent. Hot, warm, and cold. For hot, we recommend time series insight. For warm, Cosmos DB. And for cold, we recommend blob storage. Excellent. Great. It's great to be here. I'm going to hang on for the next few minutes to answer any questions. Feel free to write to me or reach out to me after the session. Thank you.